Today we're going to look at the proof of the theorem that states that if two triangles are equiangular, then their sides will be in proportion. So in this case, we're given two triangles, ABC and DEF, and in these two triangles, we are given that angle A is equal to angle D, B is equal to E, and C is equal to F. And what we're wanting to prove is that AB over DE is equal to AC over DF, and that's equal to BC over EF. Obviously, if we prove it the other way around, in other words, DE over AB, DF over AC, and EF over BC, it means exactly the same thing. Okay, so we start with the construction, and what we need to do is to plot the point J on the line AB so that AJ is equal to DE. Similarly, we plot K on AC so that AK is equal to DF. We then join JK. It should now be pretty obvious that the triangle we constructed, AJK, and the original smaller triangle, DEF, have to be congruent because we've constructed AJ equal to DE, we've constructed AK equal to DF, and angle A is equal to angle D that was given. Hence, AJK is congruent to DEF, reason side angle side. Obviously, you'd have to write that all out properly. You can see your textbook for that. Now, because those two triangles are congruent, we can conclude that angle J1 has to equal angle E. However, angle E is equal to angle B because that was given. So if J1 is equal to E and E is equal to B, then obviously J1 is equal to B. But those angles are corresponding. And if corresponding angles are equal, we can therefore conclude that they must lie between parallel lines. So JK parallel to BC. This scenario is now one that we've seen in the previous theorem. If we have a line parallel to a side of another triangle, we then know that that line has to divide the sides in proportion. So we can draw the conclusion that AJ over AB is equal to AK over AC from the proportionality theorem. Obviously, if I had to go AB over AJ equals AC over AK, that's also absolutely perfectly correct. However, we know that AJ is equal to DE and AK is equal to DF, AJ equal to DE, AK equal to DF, from my construction, which means I can now replace the AJ with the DE and the AK with the DF. That now gives me DE over AB is equal to DF over AC, which is what I wanted to prove in the first place. However, if we wanted to prove other parts of the statement up here, so we have done the first fraction, the ABDE. Don't worry that our fraction is upside down, it makes no difference. And we have done AC over DF, so the first two fractions. If we are wanting to prove the first equal to the third or the second equal to the third, all we need to do is change our construction in such a way that we can put ED on BA. So you're going to put your point there so that DE is equal to BJ, and you can plot K on BC so that EF is equal to BK. And in a similar way, we prove that two small triangles JBK and DEF are congruent, hence KJ is parallel to CA, and then we can use the proportionality theorem again. Of course, you could also have put your construction, let's just erase that. You could also have put your construction so that you have your triangle, you know what I'm trying to do here, and DEF is congruent there, and hence those two lines are parallel. All depends which part of these fractions you're wanting to prove equal. But you can get that last bit written out perfectly in your textbook. Don't forget, you need to learn these theorems.